So the definition of a polynomial function is fx equals to, suppose if we want to make something, then a general form will be a x to the power n. This n has to be some non-negative integer. This n has to be some non-negative integer. That's the condition. So let me give you an example. What does it mean? It means, let's say sorry, so it means, let's say we have some function, something like fx equals to 2x to the power 1 by 2 plus 3. So you see the power n here and this power 1 by 2 here, is it an integer? This 1 by 2 is not an integer. Integer means what? Integer means some some positive, some numbers like -3, -2, -1, 0, 1, 2, 3, dot. But this word non-negative says this negative number we have to cancel out. That means only this 0, 1, 2, 3, and this way it will continue. Only these numbers can be the power. So according to that definition, this is not example of polynomial function. Let's write fx equals to x to the power pi plus 2. Now you see pi means 3.1416, so basically that is a decimal number. Decimal number is not in the integer list, so it is not polynomial function. Let me write another one. Fx equals to, let's say fx equals to root x plus something, or just only root x, no problem. This is also not a polynomial function because root x means x to the power half. This root means x to the power 1 by 2. So this is also not a polynomial function. Let's write fx equals to 1 by x squared. This is also not a polynomial function because this x squared is a denominator. If you if I write on the line, then it becomes x to the power minus 2. Basically, if we bring it to the normal in its normal shape, then it becomes like this. So basically this is negative, but our condition is it has to be non-negative. So that means it is not a polynomial function. So then what type of function will be polynomial? All are not polynomial function. Then which one will be the polynomial function? If you want to see, some example can be like, let's say fx equals to 2x cube plus 3. This is a polynomial function, and actually it follows all the definitions of the polynomial function. Then if I write fx equals to minus 2.3 x squared plus 2, no problem. You see there is a decimal number above in the front of this. I'm really sorry. This with the 2.3, which is the value of a, so we have no problem with that. So basically we can count it, and this is allowed. I mean, we can take it. So this is allowed to take, and the other values are not allowed to take. And we can give another value, which one is like fx equals to let's say some variation. Suppose x cube divided by x. Now interestingly, this is also a polynomial function because you see this x square, x and x cube can be cancelled out. So ultimately, basically what is remaining here is x squared, and this x squared, this 2 is actually some non-negative integer, so it actually fits within the definition of our of the question of the definition of the polynomial function. So it actually fits there, so we have no problem with this. Then then we say fx equals to let's say x squared plus 2 divided by 3. This is also polynomial function, and we also do not have any problem with this because there is a 3 down here, but it's a constant number, so we have no problem with this. These all are actually polynomial function. These all are polynomial function. These all are polynomial function according to the definition. So the definition of polynomial function is in this format. This can take more terms, by the way, no problem. I mean, it can take a lot of terms, no problem with that. Just only the power of the variable has to be the non-negative integer. That's the condition for this. Anyway, thanks for this. Basically, this is a tryout. We will try to improve the quality of this. Thanks.